Hi there, this is video F22 on compound interest, and it is practicing solving for P, solving for principal or solving for present value. I think I'm going to say this every video. I would suggest you turn this off, do the questions, and then turn it back on and check your work, or it might even be faster to check your work with the answer key first. And then if your answers are not right, then you can watch the videos. All right. Jeannie is 18 years old. She's inherited money from relatives. She wants to buy a house. Okay, so this looks like what we're going to end up with. And she's 30 years old. Okay, so paying attention there. We got two ages. So I know right away we're going to have to subtract to see how many years that is between 18 and 30. And 6.5%. And we got to remember to look for compounding. So APIN. So she wants to buy a house worth $170,000. That's what she needs. That's not what she has now. So that's our A. That is our amount at the end, our amount in future value, accrued value. I think I'll just stick with amount at the end. Okay, so what does she have now? I don't know, because it says how much does she need to invest now? Don't know. That's the point of the question. Now investment is 6.5 divided by 100. Oh, I'm doing this backwards. That's okay. Annually, 1. Again, I know dividing or multiplying by 1 seems silly, but if you get into the habit of always doing that compounding, you're always going to look for it and you're not going to forget, oh, do I need it this time? Do I don't need it this time? Just use it all the time. This would be 0.065. And okay, so she wants to do it when she's 30. She's 18 now. That should be 12. But I really don't want to do an entire question wrong. Yeah, 12. That's going to be 12 years times 1 is 12. Okay, here we go. A is equal to P 1 plus I to N. 170,000 is equal to P 1 plus 0.065 to the 12. 170,000 is equal to P 1.065 to the 12. 170,000 is equal to P times 1.065 power of 12. 2.12909 dot dot dot. That's what we're going to divide by. Oops. 2.12909. And again, I'm just using the x to the minus 1 button. This one. And it gives me answers minus 1. So essentially all that does is it takes this and makes it 1 over it, which is what this is. So if we do that, and then we multiply that by the 170, 0, 1, 2, 3 more zeros. Okay, so 79,846.09. There you go, 79,000 is what she needs to invest now. There's our final answer. Always do a quick check, right? She's going to invest $79,846.09 now, and in 12 years, that's going to hopefully be worth $170,000. Most common mistake people make is they're going to put the 170 there, and then they'll do the whole calculation, and then they'll get like 4.5 million. And they'll be like, oh, good, there's the answer. It's like, no, pay attention. This is what she has to invest now. You're not going to invest like $4 million now and end up with $170,000 later. So just a quick check, and it will make your test so much better. Because if you get all happy and you give me a crazy answer and you don't say anything saying, this can't be right, I'm a little hard with the market. Always, 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 please check to see if your answer is reasonable. Okay, let's talk about Mike and going to Disneyland. He wants to take his family to Disneyland in 5 years. He estimates the trip will cost $14,000. How much does he need to invest now if the account will earn 9% compound? Okay, so we got a time, we got some money, and we got a percentage, and we got some compounding. A, P, I, N. 5 years. Times compounded monthly. And if you're wondering why shall we start with N first? I don't know. For me, it's the easiest. So I start there. I'm feeling smart. Now I'm going to keep going. Now my interest rate is 9%. This would be 9 divided by 100 divided by 12. $0.0075. All right, just want to double check. Now, this is what it's going to cost. He wants to know what to invest now. So he doesn't know the present value or the principal right now, but he wants to end up with this much in his savings account. 14,000 is equal to P, which I don't know. 1 plus 0.0075 to the 60th. Add them together. Now we're going to do our exponent. P 14,000 is equal to P times 1.5668. So I'm going to go -1 and then times 14. 1, 2, 3. Oh, excuse me. So he needs to put in $8,941.80. Okay, so we got 795. So that 5 makes the 9 go up 1, and then the 9 makes the 7 go up another 1. Okay, so there we go. Now, if at this point you're looking at these questions and thinking, oops, sorry, who has $8,900 to just randomly put away to go on a trip to Disneyland? Well, the truth is we're going to get into annuities next, which are savings accounts where you put a little bit away every month. It's not often that you're just going to have these great big gobs of money that you can store away for something that, I don't know, you won the lottery, you won some kind of a contest, you inherited some money. Your average person isn't just going to have that kicking around. Anyway, we're going to get to annuities in a little bit. All right, last one. Bob wants to set up a music studio. He estimates it will cost $40,000 to pay for all the stuff he needs. If he wants to set up a studio in 4 years, how much does he need to invest at 9.6 quarterly to save for it? No, I'll say quite a bit. All right, here's what we need. Here's what Bobo needs. There's our years, there's our compounding, and there's our interest. So we should have everything we need. A, P, I, N. All right, 4 years times my compounding period. 16 times that money is compounded at 9.6% per year. needs to be, first of all, converted into a decimal, and then divvied up for each of the time periods. So 9.6 divided by 100, divided by 4, 0.024. And he wants $40,000 at the end, and he wants to know what to invest now. So this goes, 40,000 goes up here for amount at the end. So A, P, 1 plus I, N, 40,000 is equal to P, which I don't know, 1 plus 0.024, 16. Let's add that up. 1.024, 16th power, 1.024, 16th power. So 40,000 is equal to P times 1.4615, and a bunch more numbers. That times it by 40,000, 2, 3. All right, 27,000. 369.1. And there's our final answer. All right, you should be getting really good at solving these questions.